All right, now finishing up our chi-square content by moving on to the slightly more advanced two-way chi-square. So whereas the one-way chi-square is about whether or not there are differences that exist within the levels of a single categorical variable, the two-way chi-square, on the other hand, will be looking at the relationship between two categorical variables. So I've mentioned that, for example, if you wanted to put gender into a correlational analysis and run a Pearson's R, you can't do that because the analysis would be fundamentally uninterpretable. A Pearson's R necessitates the use of data that is interval or ratio. So if, let's say, you do want to look at the relationship between multiple categorical variables, the two-way chi-square will be for you. Okay, so your two-factor or two-way chi-square test is used to assess whether or not two nominal variables are independent from one another or are related to one another or associated with one another. This is why it's often referred to as a test of independence, right? Are my variables related to one another? That is to say, are levels of one dependent on levels of the other? Or are they unrelated, i.e., independent? So, my example, this is a little bit out of date, but if you follow the news, you may remember about a year or so ago, current Senate Majority Leader Mitch McConnell announced a bill that was set to legalize hemp as an agricultural product. And his explanation was that hemp was an important agricultural product in the history of his state of Kentucky, and that it could be a really important agricultural product going into the future. And that bill actually did pass, which is pretty cool. If Mitch McConnell could now get to work on sending me another stimulus check, that would be tight, but we'll see what happens. All right, so in my example, let's say we set to poll 800 Ohio residents on their opinion on hemp legalization. Let's say, though, I was interested in whether or not there were gender breakdowns on opinion towards hemp legalization. So, in order to set ourselves up for your two-way chi-square, the idea is that you would need to ask a number of men and women about their opinion, and would need to have the frequencies reflecting the breakdown of opinion in men versus women. And the basic approach for the two-way chi-square will be asking ourselves whether or not gender has anything to do with opinion on hemp legalization, or if those two variables are independent of one another. So your data might look something like this. You would need to have the full breakdown of combination of both of your factors, right? The number of women who said legalize it, the number of women that said no opinion, and the number of women that said stay illegal. This presentation of data right here is what we call a contingency table because it shows us the frequency breakdown of one variable and its contingency on the second variable. So what you have here is your 6 cells representing your frequencies of all of the women who had their various opinions and the men and their opinions. And this is going to be what allows us to evaluate whether or not men and women have different opinions. Another thing I'll note about this contingency table before moving on is that it also displays what we call our marginal totals, right? I want to know the total of people, regardless of gender, who said legalize it, right? That 352 represents the total number from the legalized column, right? The marginal total for no opinion, that 296 representing overall men and women who said no opinion, likewise for stay illegal. Then looking over to the marginal total column to the right, that shows the total number of women and the total number of men. We're going to need those, so make sure that you can understand the difference in the contingency table between all of the 6 cells representing the frequencies completely broken down, as well as those marginal totals. Okay, to sum up all 6 of those cells gets you to that overall N of 800. Lastly, one thing that I'll note again before moving on is that to get the total number of participants based on the marginal totals, make sure that you understand that the marginal totals reflect the frequencies collapsed across one of the variables. So if you were to add up all of the people that said legalize, all of the people that said no opinion, and all of the people that said stay illegal, regardless of gender, that sums up to 800. So 352 plus 296 plus 152 gets you to 800. Separately, the marginal total column to the right, that 410 women, and 390 men, that separately adds up to 800. So, one thing you're going to make sure you don't do if you're ever adding up the sample size from the contingency table is do not add up all of the marginal totals from the bottom and on the side, because that would end up counting everyone in the sample twice. So to get your total sample size, you can add up all 6 of your cells or the totals in the marginal row at the bottom or the marginal column to the right, but not both marginal totals to the right and on the bottom, because that would end up with an n that counts everyone twice of 1600, and you don't want that. Okay, so now on to calculating the expected frequencies for each of the 6 cells. The null hypothesis for your two-way chi-square is that the variables are independent of one another. That is to say that the proportion of people who indicate the various opinions should be roughly equal for women and for men. So the way you actually need to obtain your expected frequencies is a little bit more complex than just dividing the sample size by the number of cells. The reason is that you want to factor out the fact that there are, for example, more women in the sample than men. Additionally, there were more people that said legalize overall than either of the other two options. We don't actually care about that, though. We don't care about the differences within each of the variables separately. What we care about is whether or not the proportional breakdown is different between men and women. If we were to just take the overall sample size and divide by k, we are not taking into account the fact that there are more women than men. We need expected frequencies that take into account the differences within each of the IVs, such that what we get are roughly equal proportions. So this is going to be your equation for calculating your expected frequencies for your two-way chi-square. So this is when you're going to need to know. Jade, all right, come here. Come here. All right, sorry about that. So to get your expected frequencies for each of your 6 cells, what you're going to need to do is identify the cell that you're currently trying to get the expected frequency for. You need to get the row marginal total and the cell's column marginal total. Multiply those and divide by the sample size. Okay, so for example, if you were in the legalized women cell and trying to get the overall expected frequency, you would need to find the marginal total associated with that cell that's both at the bottom and to the side, multiply it together, and divide by your n, which is 800. So this is just my expected frequency for women who said legalize it. So on and so forth for all of my remaining groups. So this is what it would look like. Again, when you're trying to get the expected frequency for, let's say, men who said no opinion, the idea is once I'm in that cell, I find the marginal total beneath it, so that 296, the marginal total to the side of it, so that 390, divide by 800. So you go through and you repeat that process of using that expected frequency equation for all 6 of your cells one at a time. So this would be your basic setup for getting your expected frequencies, and then you would just need to compute them. So this is what my breakdown of expected frequencies would be. Again, note that, for example, all of the frequencies are a little bit higher for the women. That's because there are more women in the sample, but you don't care about that. If you wanted to know whether or not women were overrepresented in the sample, you would just run a one-way chi-square. That's not the question currently under contemplation. It's do men and women have roughly the same proportional breakdown of opinion? So you don't care that there is a higher frequency of legalize it. You don't care that there were more women than men. You want to factor that out of your equation for expected frequencies. So that's why the process of getting these expected frequencies takes a little bit more work to get to than just taking n divided by k. So this would be my expected frequencies, and once I do that, my computation for the chi-square is the same. It's just that I need to do this for now all 6 of my cells. Okay, so I need to go through and get that observed minus expected squared divided by expected, one at a time for all 6 of my cells. So women who said legalize it, women who said no opinion, women who said stay illegal, so on and so forth for the men. And then from there, the obtained chi-square is just going to be the sum of all of those values that I've computed. So this would be my overall obtained chi-square, 20.02. This is my obtained statistic that I evaluate for significance by assessing whether or not it exceeds your critical chi-square. Now for your two-way chi-square, the degrees of freedom is going to be the degrees of freedom for your first factor multiplied by the degrees of freedom for your second factor. So the number of levels within your first factor minus 1 times the number of levels for your second factor minus 1. Okay, so our degrees of freedom in this case is 2. This first 2 represents the degrees of freedom for your opinion factor, right? There were 3 options for opinion: legalize, stay illegal, no opinion. So 3 minus 1 is 2, times the degrees of freedom for your second factor, which was gender. The levels for the gender factor was men, women, so 2, minus 1 is 1. So your degrees of freedom for your two-way chi-square is just multiplying together the degrees of freedom for your first factor by your degrees of freedom for your second factor. So for your degrees of freedom of 2 with a critical probability value of p equals 0.05, this same critical probability value pops up. We evaluate whether or not our obtained chi-square exceeds the critical value. If so, we reject the null hypothesis. So in this case, we have achieved a significant chi-square, right? Our obtained chi-square of around 20 obviously vastly exceeds that critical chi-square of 5.99. So we reject the null hypothesis. What that means in the context of a two-way chi-square is that your two categorical variables are associated with one another. That is to say, they are not independent of one another. What this means is that the variable of gender is impacting the opinion breakdown. Okay, so this is important to keep in mind. What does the significant two-way chi-square actually tell you? So what you want to do is you need to think about how gender is impacting opinion breakdown. And again, you can revisit the actual obtained data and figure out which one of these cells represents the greatest deviation of observed to expected. Right? It seems like the significant chi-square is primarily driven by the overrepresentation of men in the legalize it group and the underrepresentation of women in the legalize it group, and the overrepresentation of women in the no opinion group. So what this tells us is that men and women don't have the same breakdown of opinion. Okay, again, the two-way chi-square is all about how the two categorical variables are related to one another. So again, we don't care that overall there were more people that said legalize it. That would be the question for a one-way chi-square. What we're contemplating and analyzing here is whether or not gender is impacting opinion breakdown. So that's what the significant chi-square tells you. Okay, so I'll move on to a practice problem. Again, I'll set you up by explaining the problem. I would pause this video and take about 10 minutes or so to try and compute your two-way chi-square. So let's just take a similar polling data type hypothetical. Let's say we want to evaluate whether or not men and women have different breakdowns of political affiliation. So in this case, our contingency table shows the women who identify as Democrat, Republican versus Independent, and likewise for the men. So take this data and collect your expected frequencies, run your chi-square. I would recommend about 10 minutes to complete this problem. When that's done, come back to the video and see how this problem would be completed. All right, so now let's walk through this practice problem and see what we get. So first, you need to compute your expected frequencies for all 6 of your cells. So in order to do that, you would use this equation provided for you. I would definitely include this equation in an exam for you to use. You need to get the marginal totals for each cell, multiply them, and divide by the overall n. So your expected frequencies for your 6 cells would look like this. Again, you go into each cell one at a time, you get the marginal totals from the bottom and the marginal total from the side, multiply it, divide by n. This again gets you a set of expected frequencies that reflects the fact that there are more women than men in this sample. Again, you don't care. If you wanted to know whether women were overrepresented in this poll, you would run a one-way chi-square on the marginal totals, but that's not the question of the two-way chi-square. right? There were more women than men in the sample, so all the expected frequencies for women are higher. That's because we don't care that women are overrepresented in this poll. All we want to know in the two-way chi-square is whether or not gender, political affiliation breakdowns are different. So then from there, you start computing your chi-square. Again, you need to create this table where you compute that observed minus expected square over expected, run down the line, and do that one at a time for all 6 of your cells, not looking like there's a particularly huge magnitude of a difference between observed and expected for all these cells, but you need to compute your overall chi-square and figure out whether it's significant. So your overall obtained chi-square for this problem, 3.57. That's the obtained statistic that we evaluate for significance. Again, your degrees of freedom for a two-way chi-square is going to be the product of the degrees of freedom for factor 1 and the degrees of freedom for factor 2. So again, same critical chi-square value of 5.99. Does our obtained chi-square exceed critical? No. In this case, we do not reject the null hypothesis. So what does a null two-way chi-square tell you? It tells you that your two categorical variables are not related. They are independent of one another. Women and men do not differ in political affiliation breakdown. Okay, so that'll do it for the two-way chi-square. I hope you're all well, and I'll talk to you soon.